Pleasant day to everybody. I am Zara Gwen Bagin.
And I am Joseph David L. Romanos under the advisory of Engineer Maricler over to NASA.
Today, we will be presenting our study entitled Mercury Removal from Small-Scale Gold Mining Wastewater using chicken feathers as a low-cost adsorbent. Small-scale gold mining has been going on for decades in Mindanao, notably in the infamous gold rush areas in the Davao region. The majority of small-scale gold mining in these areas uses mercury amalgamation. The amalgamation method ultimately produces wastewater contaminated with mercury that is, if disposed to the natural environment, affects the health of the organisms around the area. For this reason, it is empirical to prevent the heavy metal contaminated water from getting to the natural systems. Biomaterials such as chicken feathers appeal as an effective material for mercury removal. Chicken feathers constitute keratin, which are thought to provide polyelectrolyte properties and enable them to act as ion exchangers.
Objectives of the study. The study intends to contrive a viable and low-cost solution to the removal of mercury on small-scale gold mining wastewater through accomplishing the following objectives. So first is to verify the effectiveness of chicken feathers as a low-cost adsorbent to remove mercury from small-scale gold mining wastewater. Second is to gain knowledge of chicken feathers adsorption capacity by conducting a laboratory-scale batch adsorption experiment using sampled wastewater from an actual small-scale gold mining operation.
The methodology for study consists of 1. Collection and pre-treatment of samples, which includes the initial mercury analysis. 2 is a batch adsorption test, which includes the final mercury analysis. 3 would be the treatment of data, in which the analysis of the data from the experimentation is carried out.
So the first diagram shows the process flow of wastewater collection and its treatment. So first is the wastewater samples were collected every 30 minutes of interval in a 1 liter polypropylene bottle from a tailings collection tank of a ball mill facility in Andilimawa, Davao de Oro. The untreated wastewater was then stored to be sent to a laboratory for initial mercury analysis using cold vapor atomic absorption spectroscopy. Each sample is subjected to setting for 60 minutes, and afterward, the wastewater sample is filtered and then stored to be used in the batch adsorption experiment.
The second diagram shows the preparation of the adsorbent material. Raw chicken feathers were collected from a poultry farm in Maco, Davao de Oro. It is washed and rinsed several times with detergent and distilled water, and then air-dried for 1 week to evaporate the water. The chicken feathers are then soaked with 0.2 N sodium hydroxide solution for 10 minutes as pre-treatment before being placed in a ventilated oven for 24 hours at 50 degrees Celsius to eliminate the residual moisture. The barbs were carefully cut into 0.5 cm length, discarding the rachis. The chicken feathers will then be used in the batch adsorption test. And lastly, this diagram shows the flow of the batch adsorption experiments that was performed. The experiment was carried out by adding 1 gram of chicken feather adsorbent to 50 ml of small-scale gold mining wastewater, 100 milliliter beaker. The system was steered adequately on a magnetic stirrer at 200 RPM during observed contact times of 60 minutes, 120 minutes, and 180 minutes respectively. Following that, Whatman 125 mm filter paper was used to separate the two phases. The treated wastewater was carefully stored in specimen bottles before sent for final mercury concentration analysis.
As a summary, the study used chicken feathers as a low-cost adsorbent in removing mercury from small-scale gold mining wastewater. The researchers investigated the metal uptake, adsorption efficiency, and the effect of contact time of the adsorbent material to the wastewater through a batch adsorption test. The adsorbent material's performance was assessed by comparing the mercury concentrations in treated and untreated wastewater. In this investigation, quantitative analysis was used. Results and discussions. The table shows the concentrations of mercury analyzed by cold vapor atomic absorption spectroscopy from the small-scale gold mining wastewater sample before and after the batch adsorption test using chicken feathers as adsorbent.
After the batch adsorption test, the chicken feathers successfully adsorbed mercury metals and reduced the mercury concentration level of the small-scale gold mining wastewater with more than 90% efficiency. It was observed that the adsorption efficiency increases with the increase of contact time. At 60 minutes of contact time, 95.83% efficiency was achieved. An apparent rise was exhibited after 120 minutes, where adsorption efficiency is at 96.85%. The optimal adsorption efficiency of the chicken feathers was reached after 180 minutes at 98.09%. Metal uptake. It is plotted in this figure, indicating the concentration of adsorbed mercury metal ion per gram of adsorbent for each contact time observed, and the results for average metal uptake also exhibited an increase as contact time increased.
The study used the ANOVA method to analyze whether the measurement changes from the untreated to the treated water samples in the means of the adsorption efficiency have a significant difference. Determining which of the contact time observed was more effective to employ in the study was based on the p-value results. Standard p-value is 0.05. One-way ANOVA exhibits a significant effect on mercury level concentration after applying chicken feathers as adsorbents with a p-value less than 0.001, suggesting that there is a significant difference in the effect of using chicken feathers as a low-cost adsorbent on the measurement of mercury concentration before and after the treatment of small-scale gold mining wastewater. And as for the comparison of observed contact times, post-hoc data from ANOVA suggests that there is a significant difference between each contact time used in the study for mercury adsorption. It is indicated in this table where differences are flagged at a p-value of less than 0.001. And as for the comparison of observed contact times, post-hoc data from ANOVA suggests that there is a significant difference between each contact time used in the study for mercury adsorption. It is indicated in this table where differences are flagged at a p-value of less than 0.001.
After batch adsorption tests with contact times of 60 minutes, 120 minutes, and 180 minutes with an adsorbent dose of 1 gram per 50 ml, the efficiency of the adsorbent was observed to be at a maximum during the 180 minutes contact time, with average values of 98.09% for adsorption efficiency and 3.03189 raised to the negative 8th power mole per grams for mercury metal uptake. The treated wastewaters measured final mercury concentrations were within the government regulatory limit for Philippine Class C waters. The regulatory limit for the mercury is set at 0.005 milligrams per liter, in which the treated wastewaters mercury concentration satisfied after 120 minutes of contact time at an average of 0.0039 milligrams per liters.
Following the above conclusions, the researchers' recommendations for future works and the improvement of the study on chicken feathers as a low-cost adsorbent are the following. First is further tests need to be conducted using chicken feathers to treat small-scale gold mining wastewater by applying a larger amount of wastewater and chicken feathers. The second is the parameters, namely dosage, temperature, and pH should also be observed. The third is column tests should also be observed to determine chicken feathers behavior and performance, wherein the constant flow rate is observed before it is applied at a pilot scale treatment. And fourth is desorption and regeneration studies must determine whether the chicken feathers can be reused for further adsorption. And lastly is study on how to dispose of the adsorbed mercury metal is essential.
Thank you so much for listening.